to begin, maybe I'll contrast with what Chris just talked about. I think something I've always been interested in is the long tail of applications, right? So there's a disproportionate amount of attention that you get when you have an enterprise, when you have an IT team, and even with the data programming, there's a set of programmers who are ready and willing to write these sort of functions. And we've been, originally I was interested in the natural sciences, I did a lot of work with astronomers and oceanographers and so on, and more recently I've kind of turned 90 degrees or 270 degrees or whatever the number of degrees is into the public sector, where the challenges are a little different. And so, they're not extremely large, but they are still extremely difficult. What I think it shares in character with what Chris was talking about, though, is that, I used to have this slide, and in fact, I've got to go teach a class in an hour, so I got to go find a room to do it online. And, it was always the joke about, well, the data wrangling is 80% of the work, and then the communicating the results was the other 80% of the work. And but the amount of attention that people put on the middle step of defining the model, that was huge, even though it actually wasn't wasn't what was keeping people up at night. And so I absolutely agree that where are you going to get the training data and how you manage that is the big problem. Okay, so let me spend a little bit of time on data science in the public sector, just to give a couple of examples and a couple of challenges, and then try to describe what we try to mean by semi-synthetic data sets. And we're not very good at marketing, so if people have suggestions for terms for this, there's downsides of using the word synthetic, but there's also downsides of using the word repaired, and it's somewhere in between synthetic and repaired. And then I'll talk about some of the technical results we have on what we're actually trying to do. So these are cherry-picked kind of fun examples, but we have a data science for social good program at the University of Washington. We stole the name from the University of Chicago, but in general, trying to tap into this resource of students want to do more with their time than just push in their own field. So we get people from criminology and astronomy and everywhere else, and computer science, of course, and everywhere else to sort of work on these problems during the summer. And so one example was, you can go to a new city and ask Google to give you walking directions from point A to point B, but that will happily take you over curbs and upstairs and down steep hills, making it absolutely useless for people with mobility issues, or if you're pushing kind of a cart of freight or anything else. And so there was this black market of online forums where people would pass around hand-drawn maps to try to get around a city. And the idea that Anat had and her team said, well, we can do a better job than that. So they accessed a bunch of open data that showed you gave you where the sidewalks. But problem one was, the sidewalks would do this or they would do this, but they wouldn't line up properly, so you couldn't actually do routing algorithms on them. And so they had to sort of do a bunch of computational geometry to kind of figure that out and do that all in Postgres remarkably. Another problem was the coverage, and so they have an app where people can download and crowdsource this and walk around on campus and sort of track where they're walking and get a better job of coverage of the sidewalks and so on. And then, version 3 or 4 of this, you can start doing really interesting analytics. So this is a snapshot of a place in downtown Atlanta with kind of an isocontour map of effort required to get around. And the idea is, with a certain amount of effort budget, you can get this far, but if you unlock the doors in the First Union Bank building on the first floor, then you can on the weekends, then you can access the elevator, and all of a sudden with the same amount of effort, you can get much, much further because you can take the elevator up instead of going up a steep hill. And so this kind of map can't be drawn without doing all this other preliminary work beforehand. So this is cool, and it gets pretty deep. Another thing we've been involved in, it started with the Data Science for Social Good program, where the Bill and Melinda Gates Foundation submitted a proposal to us, and so we had to kind of stare at that for a second because usually the resources are flowing the other direction. But we said, sure, why not come and hang out with us for the summer? And what they were interested in was they were spending, on the order of millions of dollars to consultancies that would produce approximately Tableau workbooks on descriptive statistics about the data, and so they weren't terribly satisfied with that. And we accidentally embarrassed a bunch of people by doing more in the summer, with a team of students than they had for multiple years. But the problem was roughly this: if you're trying to deliver services to homeless families, there's various pathways through these services that they take, right? They might go to emergency shelter, then to transitional housing, then to rapid rehousing, or they might go to job training and so on. And it's unknown which of these pathways is more efficacious than any other. And especially if you break it down by condition on demographics and so on, nobody really knows any of this because none of the data was pooled together in one place. And so as usual, you spend 80% of your time on, I kind of hate the term wrangling because it kind of implies we don't know what we're talking about, and we do. There's a lot of good work on modeling that process. But that step of cleaning it up was most of the work. And then you can sort of do some of this analysis where you can find things that people already know, such as, well, let me ask you this. Emergency shelter to transition housing has a low percentage of successful exits. What is a conclusion you might draw from that? Is it that emergency shelter programs are not working? And by my tone of voice, you can tell that I'm tricking you. What's another interpretation of that?
Guess the hardest cases.
It's the hardest cases, right? If you emergency shelter, there's some kind of domestic violence case or there's something else going on. And so this highlights kind of another reason, or one of the reasons why working in this area is challenging. It's not, you know, what people are worried about when they're sharing data, they'll say it's about privacy, but they're worried about misinterpretation and somebody drawing a bogus conclusion. A reporter puts out a piece, you know, the Republicans pick it up and sort of manage to cut funding or something. So the whole thing is very, very fraught politically and societally, and yet there's a huge opportunity for these methods to be applied, and so we're trying to navigate that. I debated about whether to put a slide in here on this, but the open data movement is a big deal. We're all very happy with it, but in some sense, it's failed, right? It's dumped out a bunch of data sets. They're not really being used at the same rate that people expected. There wasn't this huge marketplace of cool apps that emerged, and there's a number of reasons for this, but roughly, it's it's a convenient sample of the data sets that are actually available in the cities, right? It's not the important ones. It's not the valuable ones. They're redacted in various ways. They're cleaned up. They're aggregated, and so on. And then also there's a data integration problem where it's a big soup. So this doesn't really solve the problem. So here's my little cartoon of what's kind of going on. It used to be the case that subject matter experts and before they were called data scientists, people that did the analysis were either the same people or they were sitting nearby each other. And then over time, they kind of went to a different department within the city agency. And as the methods got more advanced and as you started working with larger and larger data sets, they popped out and you started to rely more on consultants and students at the local university and so on. And this is a little bit dangerous, right? It's physically easy to pass the data over, but once you go outside that boundary, all sorts of bad things can happen. So what doesn't go with the data typically? Metadata. Well, and maybe more broadly, I'd say just context, right? There's a lot of, so you get these cases where, some colleagues of ours will look at traffic data in New York and say, look, we found this really interesting signal where there was no traffic along this roadway during this one period of time, and it sort of shows up in all kinds of data sets. Pretty cool, huh? And it was like, yeah, there was a parade there, right? We know that, right? That wasn't striking. And it seemed like, so things that we'll be surprised by as data scientists are not surprising to subject matter experts, and vice versa. That's a pretty innocuous example, but there's worse examples. So the reality here is that because they're worried about this context going with the data, you end up with data sharing agreements are the law of the land, right? You end up with a very difficult conversation where you say, well, write down exactly what you want to do with the data, and then I'll go see if I can get approval for it and so on. And the whole point is like, well, I don't know exactly what I want to do with the data. I thought you wanted help with this. We have to work with it and look at it before we know that. And so privacy and politics and people's own personal promotions and press and so forth, all these things make it difficult to share data. And there's this quote, collaborations move at the speed of trust, and there is none once it's outside the organization. So the reality is you end up having all these pairwise agreements between individual faculty members and city agencies as opposed to anything centralized. But that's not really the reality either, because it's too expensive to do all these negotiations. And so what you have is some city agencies don't get any help at all because no one's really talking to them. Other researchers say, you know what, in fact, most researchers, I would argue, say it's too much trouble to go, sign. I don't want to lawyer up and have to sign all these data sharing agreements. I don't want to go have 1-hour meetings to talk about things. I don't want to write down especially what I'm going to do. So I'll just put on I'll rely on toy data sets to drive all my research. And this characterizes, I would claim, a great majority of computer science research. So it's very sparse. And so what we want to do is put something in the middle here where you can dump things in, and then you work on synthetic data first, realistic synthetic data, and I'll describe what I mean by that. And then, if your results look promising, you can come back and kind of re-up and then go through, now you have enough information to go through the trouble to bother signing a full-fledged data sharing agreement, or throw the code over the wall and let them run it. But regardless, you've done that kind of debugging exploratory phase on your own. Another thing I was thinking about, I was sending messages to a couple of students on Chris's talk, because I've seen versions of that before, but there's some exciting stuff in that. There's this coverage of the space, right? I mean, a training data set is this convenient representation of the empirical distribution you're trying to learn, right? We're not getting coverage of that space because we don't have access to all the data sets that are out there, right? We only have access to these small samples. So 1,000 data sets, many of which are synthetic but sort of realistic, seems better to me than a relatively small number of high quality ones that are currently driving our research on models and so on. So we're trying to I want to see more interesting cases like homelessness and sidewalks and everything else in all the papers that we write in computer science is one of my goals here. All right, so we're trying to build this thing. We have this socio-technical, legal, governance structure for sharing data, and we published a paper recently in the Fairness, Accountability, and Transparency Conference. Fine. So the uses in Fetta Data, this is not a new idea. And recently it's gotten very popular for training models. There's 30 years of research or more on using it for privacy reasons. There's also kind of a coverage reason. You know, you can't get data from all parts of the distribution you want to explore, so you simulate things in order to try to explore that. But my concern about that is it only really helps with the known unknown, right? The same people who are writing the model to simulate to generate the data are the same people who are writing the model to go learn that function, and it gets to be a bit circular. And then I liked Todd's intro. You change one thing about autonomous vehicles and everything else is affected. That's very inherent when you start working with cities, right? You can't study waste management in isolation, right? It has to do with poverty and housing prices and like the elevation because people buy houses on the hill and they have the view and all of a sudden you get these weird effects. Not to mention hundreds of years of historical discrimination, which I'll talk about in a second. All right, so, and then the third reason might be bias, which is really where I want to focus my attention. You can only get data from your own biased system. If your system itself that you're measuring is biased, you can't get unbiased data out of it, right? You have to do something after the fact, and I'll try to make that point more clear in a second. So an example of bias, which I think many in the room can probably draw up recent examples. Amazon's been a wonderful nonstop fount of screwed up machine learning applications that we've all been able to draw on over the last year or two. But here's one that's a little bit less innocuous. This is a map of Seattle. And if you're trying to build a transportation system, you want to understand ridership. There's maybe two ways of measuring ridership. One is what we call in Seattle the Orca card, but this is the card swipe system that all cities have, right? So this is like one regional card for all, some sort of Lord of the Rings reference or something. The other way, okay, so who has Orca cards in Seattle? Say it again? Commuters, okay, who's commuting? Microsoft employees, Amazon employees, University of Washington employees. Who doesn't have Orca cards? Okay, poor people and maybe tourists. Good point, and I care about one of those. So if you design a system, so this Orca card data set is very rich, right? There's lots of attributes about this. You have demographics about the person. You know their history. You know where they got on and got off. It's a gold mine for a data scientist. If you take that data set over the wall and start modeling the transportation system and designing the transportation system based on that data set, what are you going to get? You're going to get a transportation system that works great for Amazon employees and Microsoft employees and everyone else. That's expressly not the goal of the public transportation system, right? They have an absolute mandate to be equitable. So the other way of measuring ridership is that 30% of the buses have a pressure plate on them, so when you step on the bus, you get a click and you know somebody got on. You don't know anything about them, but you know you got a click. And so Mark Hallenbach and some colleagues are not too stupid to make this mistake. You know, they're experts in this area. So you can draw a map of where these two measures disagree, and of course it lights up in areas of lower income neighborhoods. And then you can adjust for it and you're fine. My fear is that not everybody's as smart or on top of this as people like Mark Hallenbach. I think that as we start to pass data sets over the wall and get more people working on this stuff, we lose all that context and we have no idea what's going on. We don't understand the biases, we don't understand the sampling biases and so on. All right, and so the other examples here that have been in the news, there's 100 of these you could do recently, but people saw this one, I guess. Right? So why is Amazon having trouble training a model that correctly weights women? They don't have any women work. They don't have enough women that work there, right? You're training it doesn't have enough women. It's going to be difficult to sort of to correct for that, and so they gave up. Why is Google auto completing your sentences where I'm going to go talk to the CEO? He will meet me in an hour as opposed to she. Well, because there's a bunch of emails with a bunch of he's in there. Is that a true signal? I would argue no, right? That's a signal that's influenced by the entire history of sexism, right? That's not the true signal. That's the signal that's influenced from a biased system. And so it's difficult to correct for that. Maybe the most famous example that had been trotted around a lot, people familiar with this article from a couple of years ago? Yeah, so this is, recidivism models. You can debate about whether you should be predicting recidivism at all, and a lot of people that have convinced me that that's a pretty stupid idea in any context. But even if you are going to do that, this model was getting it right only 61% of the time, and it was demonstrably racist in the decisions it made, right? If you were labeled high risk but did not reoffend, you were twice as likely to be African American, and if you were labeled low risk and did reoffend, you were twice as likely to be white. This, won't stand. So again, why did this happen? Is that is it a true signal? No, it's because this is about the only data we have, the only data we're ever going to have, is data collected from our own system, which has these biases baked into it, right? We can't really get around that. All right, so what do you do? One more example. I grew up in Atlanta, Georgia. This is an article from Bloomberg a couple of years ago, where Amazon was rolling out its Prime Now delivery area, and they didn't roll it out to everybody at once, which is a reasonable thing to do. And so they trained up a little model on buying history and habits and demographics and so on. Expressly, though, they didn't use race, right? Because hey, we're above that. We're gonna make sure that our model is protected against that. Well, everybody in the north half of Atlanta got access to the service, and nobody in the south half of Atlanta. What else is true about the north half of Atlanta versus the south half of Atlanta? The north half is predominantly white, and the south half is predominantly African American. So we just relearned racial signals, even though race wasn't a part of the model, right? Okay. And lest you think this was, so why is this the case? Well, look back at the actual redlining, where the term redlining comes from, was they used to put these maps of like, don't build there and do build here. This is undesirable neighborhood, this is desirable neighborhood, and this is a famous sociological example of like where we institutionalized racism and made it official policy. Well, if you start overlaying maps, you can do the GIS work to drop this down and then drop down maps of housing prices. It's the same map, right? This stuff from 70 years ago is absolutely still affecting where people live and how they're doing it. Does that make sense? So the point is you can't get away from the signal. It's there. So what do you do about it? So my view is that raw data is a bad idea. It's something you can't use directly. This culture that we've developed of, no, my research is so important that I need access to the real data, the raw data before you touched it, is wrong. You're going to get the biased, incorrect signal, and you're going to propagate that when you train models based on it. And so in this case, the discount or the access to the service is a function of buying history and zip code and so forth, but zip code is a function of race because of the reason I just gave, and buying history is also a function of race. And so the raw data is misleading. It's polluted by 300 years of institutionalized racism. And so here's my summary provocation, I guess, is we want data from the world we wish we had, not data from the world we do have, right? And I don't care about this problem in the sense that it's not my field of study. I don't have enough expertise to study the sociology of these effects. What I do care about is that we're in the business of automating this. We're in the business of entrenching these signals and making them more difficult to study and more difficult to dislodge. So that gets my attention as somebody that works in this space. That's my problem, not the sociologist's problem, not the policymaker's problem. Okay, fine. So what are we going to do about this? We're going to try to adjust things. There's a ton of work on this. Moritz Hart has this nice slide where he talks about the number of papers in fairness in ML has kind of spiked up in this exponential graph. And we have a slightly different twist on it. Yet another example that's pretty famous, Berkeley admissions in the 70s. If you just add up admissions and look at the average, the blue line is men being admitted to Berkeley, and the red bar is women. And so it looks like admission favored men. But once you condition on department, it turns out it flips. So what's this called? Simpsons Paradox, right? So this is a thing that happens. It's not shocking. It's an issue, but it's happening a lot, right? Any kind of correlative measure is going to be adding things up. Anytime you average things, there's a chance that this might happen. And the field of study that tries to sort this out is causality. And just put another picture of Simpsons Paradox. This is it. The lines go one way when you look at individual data sets, but the lines go the other way when you take the average of them, right? This kind of effect is pervasive. So writing this down a little bit in a cartoon example, let's imagine that we have a causal model. We'll relax that assumption in a second, but we have a causal model, and gender might influence what department they apply to. Gender influences what hobbies you engage in, and your admission decision is based on department and hobbies, and obviously many other things too. This is a fragment of the causal graph. And if we like Perl or we like Rubin, we can read off the conditional probabilities here and write down an expression that says, well, the probability that they're admitted, given that the department is computer science, is some expression. Okay, and we can figure out in what situations we can do this well and what situations we can't. And Perl would say, well, let's invent some new notation where we say impose that the department must be CS, which has the effect of cutting those links in the causal graph, right? So they're no longer sort of influenced in any way. And then you drop certain factors from the expression. And so you can do this kind of a calculation. If you have a causal graph and you have some data, you can play this game and you can read all those papers and do this work. With this framing, you can think about what fairness and bias might mean. And so one approach was, look, let's try to capture the effect that the same outcome we should have the same outcome for all values of these proxy variables. And by proxy variables, I mean zip code, and zip code correlates with race. And then there's another one that's counterfactual fairness that we've had a long email thread with the authors trying to sort out a couple of technical details. But overall, it attempts to capture individual level causality, meaning for me individually as a student who applied, what would happen if I were a woman versus a man? And that's not really possible to do in general, kind of for obvious reasons. You can't really know the parallel universe where you flip someone's gender and expect. So there's some issues there. But on the first one, consider this contrived example. And you can just read the red if you don't want to read the rest. The situation is Department A rejects all men and Department B rejects all women, right? But because I've made everything else random, it's clearly unfair because Department A is rejecting all men, Department B is rejecting all women, and yet it satisfies proxy fairness, which is these conditions that are written down the middle there. And so these Simpsons Paradox types of situations confound the notions of fairness that people have proposed in the literature. All right. So our view of this is to think about the fact that there's going to be a set of admissible variables, meaning that it might be that gender influenced some things, but you do that deliberately. You say that, for example, if you are predicting recidivism, the number of prior arrests, should that be a valid variable that I use to predict recidivism or not? I think most people would probably say, sure, right? If you've robbed 10 banks, you're probably a higher risk of recidivism than if you rob 0 banks, right? And yet, can you say that that has no influence from race? There's no connection there? Probably not. So you have to be upfront about the fact that there may be edges in this causal graph that you're willing to accept, even though you know there may be influences from protected attributes like race and gender. Okay, so argue that an application is fair if the protected attribute does not affect the outcome for any possible configuration of the admissible variables as opposed to for any possible variables, which is what gets you into trouble with Simpsons Paradox. One problem is we don't actually have a causal graph. We can't imagine that everyone's written down this thing. All we have is a data set. That's okay. Babak's has some theorems that sort of prove that if you know the admissible variables, you can derive a set of these conditional independence constraints that must hold in order to imply the fairness condition that we want. Okay. And the cool thing is that we relate we think is cool, relate these conditional independences to classical database repair problems, and then we're going to scrub the data set in an according way. All right. So we have these conditional independent statements. Let me give you a cartoon example. This was there's a tetherless bike share program that is now kind of nationwide, but it was done first in Seattle, and it was a bit crazy because there was these 3 companies like duking it out, and they would pick up each other's bikes like in back of trucks and like throw them in the canal and sort of fight it out. And there was this Wired article that kind of irritatingly didn't actually talk to anybody in Seattle and wrote it anyway, but it captured the scene pretty well. So there were conditions like, you're not supposed to have more than 1,000 bikes on the street, and we were getting the data through this trusted data collaborative thing that I mentioned earlier, and it was pretty obvious just by walking around that there were definitely more than 1,000 bikes on the street, and so we were kind of in this policing role of checking to see whether they're meeting the conditions and so on. But in that context, you can build a histogram of all the trips from one destination to another, from one origin to a destination by which company and maybe gender and whether they wear a helmet or not, and some other things that the city of Seattle is interested in checking. They want to make sure things are fair, and they want to like one problem is this bike share system supporting the mammals, right? The middle-aged men in Lycra, right? This is not the goal of the if you're investing a lot in a new modality for public transportation, and the only people that get it are the ones that spend $2,000 on a bike. That's not really what the goal is. Okay, so you get some distribution across this stuff. And then you can imagine that there's a weird spike here, but this weird spike may not be because it's true, right? It could be that the Ride Corp company, which is not the real name, advertised to men in the U district, right? And so they took out an ad in a magazine, and therefore got a spike in results. And so you want to correct for that signal when you know it exists before you release that data set for other people to do analysis on. Does that make sense? So what I'm trying to do with this example is show that it's not all about racism and sexism and so on. It's also just about general bias correction. All right. And so you can do this process, do this admissible variable stuff, get some conditional independencies, and reduce it to checking for MVDs. And you might delete a tuple or add a tuple, and you want to find the minimal repair that satisfies these things. And then you can show that under reasonable assumptions, representativeness assumptions for machine learning, which is there in every paper, if you do this correction, your classifier that you train on that has to be fair by this definition, which is a nice result. Okay. Let me skip that. So fine. So then you correct this distribution and clean it up in some way because you've cut the causal edges that you know are false. And you can show that this does really well compared to other fairness metrics and agrees with other ones, even though we didn't design it to agree with other ones, it does pretty well. And it retains high utility and all that other fun stuff. The only thing I want to say about this is I like this evaluation metric, and I like to put it out there, see if people have feedback on it. I'm not satisfied with the way utility is measured for all these fairness and privacy papers. It seems a little bit arbitrary, like they just pick their favorite metric and show they do well on it. So one thought we had was take a bootstrap sample of a data set and use that to define a confidence interval of how, for whatever metric you're doing, fairness or whatever. That defines kind of a natural range, I would argue, of what you're going to get. And if we can show that we're below, that the damage we do by by applying these repairs is less than the damage you would do by a bootstrap sample, then perhaps it's a tolerable amount of damage. Does that argument make sense? I'm not sure if that came through that well. And so we showed that we checked that out, but the main thing I want to put those words out there in case somebody thinks that's a crazy way to evaluate anything. My battery's getting low as well as my time. Let me. Fine, so that's about it. We do some work on privacy, but we're not really pushing the state of the art too much. We're more doing privacy because we know we have to. And we're interested in the connection between privacy and fairness, and there's some other people that are working on that as well. Some of the cool stuff we've found recently, though, I guess, is you can think of these fairness conditions in your objective function as kind of a regularizer, and in some situations they actually improve accuracy, so there is no trade-off. That you actually, if you constrain the environment to try to be fair to people, you actually get better results than if you didn't have that term in there, which is kind of exciting. There may be some situations where applying fairness gives you free privacy because you're already kind of controlling for outliers, which is one of the problems with privacy anyway. We're not totally sure of that one yet. There's a lot of work to do on tools for end users. As I mentioned, I'm interested in the long tail here, so it's not, a lot of what the differential privacy community will do is say, here's a long list of assumptions that have to be met. I'll design you an exquisite little differential privacy mechanism that will be perfect for your case, as long as you can guarantee to me, under penalty of death, that all these assumptions hold. There's nobody that can understand the mathematics well enough to do that. And so we're trying to think about what can we do in the general case when we relax all these assumptions, what kind of guarantees can we still make? And that ends up manifesting in GUI tools that people can use. And then we want to have a better open data portal where maybe you have the real open data portal over here, that's fine, that should still exist. But then we want to have this kind of semi-synthetic data portal that is hopefully much broader, much more useful, much more relevant for people, but it's not real. It protects privacy and it corrects for bias and it has better coverage. And then the wackiest idea that we're just starting to think about is, what if you had one big city tensor, right? So you lump together the weather and the elevation and the housing prices and the business permit applications and everything else you've got, and you link it all by by lat long and time, essentially, with some kind of autoencoder trick, build up a big tensor and then release that. And now everybody can just download that and add it into their own predictive model to try to improve estimates of bike share demand, or if you're Uber, or if you're trying to predict crime or anything else. To whatever extent crime is influenced by weather and time of day and elevation and housing price and everything else, hopefully you'll get some effect on that. We haven't really checked to see whether that works yet. One of the problems here is it could be that you train up just a big block of noise and it does nothing for anybody, or maybe even makes things worse. We're not sure yet, but we're kind of excited about that because it gives you a single point of control for doing data integration and privacy and so on. And so Anion has been working on that, and we have a paper under review at KDD where she's done this specifically for bike share, but it's do fair demand prediction by making adjustments in the objective function, and it works pretty well. So let me, and then we want to build a big fancy database-like system that has all these features kind of wrapped up in one thing. The last thing I'll stop here. The point I'll leave you with is I feel like there's kind of a data science version 1.0 where there is this technological exuberance about what can we do with these massive, noisy, heterogeneous data sets, and I think there's this data science 2.0 that's emerging where it's what should we do with these data sets, and that's no less technically rich in terms of research and arguably more important. Okay, and so some of the aspects of what data science 2.0 will look like is that there's social sciences will be more in a leadership role, and there's more attention on real applications and messy data and concrete impact than you saw in the previous world. And I'll stop there because I think I'm a little bit over.
Thank you so much, Bill. That's really great. I think we all need to be thinking more about the implications and to our companies, to society in general, to the humans that we're impacting. We need to all be thinking about that a lot more. Any quick questions for Bill?
Hi. I have a question. So I was wondering that, it's a very interesting talk, and we do live in an unfair world, but I was thinking, how do you avoid, like by using synthetic data, how do you avoid producing solutions that would only work, let's say perfect world? Because I can imagine that, you would, with all these biases that we have already, like going on, the models that produce, they probably would perform better, arguably, right? Let's say in monetary sense, than models where you would control for these biases of the world and you would produce like fair in some other definition models, right?
There's a fairness accuracy trade-off that needs to be fully explored. I don't worry as much personally about the hit that online advertisers will take by delivering things fairly. In terms of money, but I do think it's an important research question to try to understand what that trade-off is. The other thing I'll say is that there's overfitting to the wrong answer that's going on. So to say that, well, yeah, boy, maybe it is, I could make more money if I discriminated against people that have this thing. Well, optimistically, I might say only in the short term, right? If you start delivering this stuff in a more fair way, besides the fact that it's the law. I mean, this Bloomberg article for Amazon. There's in fact, I guess just last week, right? The HUD suing Facebook and is about to sue Google and Twitter for exactly these reasons, right? Because they're saying you are not allowed by law to discriminate against people based on where they live. They absolutely are discriminating on people where they live, and in Facebook it was rather explicit. You could just sort of carve out neighborhoods and say I don't want to advertise there and so on. And so we'll see this. So it ends up being, even if you're completely ruthless, you don't give a shit about people at all, and you're a big company, it's going to be a compliance issue. I used to say sometime in the future, and now I'm going to say now because of last week. The lawsuit is there. So I think there's no real way to hide from this one way or the other, whether you agree with the philosophy or not.
Thanks.
I think just as a kind of follow on that, though, regardless of what your motivations are, if you create models that are not producing fully accurate conclusions, you're at risk of then drawing conclusions that, with the best of intentions of solving a problem, in the wrong way. And so there's some second order effects that you have to be careful of for creating, saying this is an inadmissible variable and therefore having a weaker model.
I confess I got a little stuck on the phrase fully accurate model. I would like to see one of those sometime. So yeah, again, there is a trade-off between these things, but it's the law, it's the right thing to do, and I think it will. Yeah, I mean, as I mentioned, there is some tantalizing results here of where by constraining the model more, you can actually get higher accuracy because sort of through some version of overfitting effects. I mean,
could you expand on that last point?
Well,
I want to hear more about that.
That's hard for me. We're going because there's only a couple people that have pointed this out, and then it's still under the knife a little bit with ourselves. But maybe one way to think about this is. If you try to build a business model that relies heavily on the fact that, well, sorry. There's two questions on Twitter. Let me finish one comment, and then I'll try to unpack that. The slightly higher level reason why I'm not convinced that it's bad for business to do this is that if you want to learn a rule that says black people never buy my product, right? Besides the fact of compliance, you don't even care about that. Let's say you can hide it, you can do all that stuff. You perhaps could invest more money on to try to figure out how to convince black people to buy the product.
Right,
and so just being to be so dependent on the training data that isn't accurate is weaker for your business overall. But I admit that that's a 10,000-foot kind of argument.
Right, but again, just to follow on, I never said anything about a financial motivation. I'm talking about if you're trying to solve a societal problem, if you rule out the use of some variables that are critical to the understanding of that problem, are you not therefore having a less useful model.
So, sorry, maybe I airballed that completely. One thing that my students mention every chance they get is, boy, you know, if I get into the business of producing bias scrub data sets, might that whitewash the impact of what's going on? Like, might it be harder to have a conversation about the fact that this bias existed in the first place and we scrubbed it out? And I'm absolutely sensitive to that. My answer there is I'm not too concerned about the sociologists picking up. I think I have a couple of slides here that I took out from this talk, but I think an open question is, how do you message this stuff properly? You know, here's a semi-synthetic data set. It's useful for these tasks, but it's not useful for these other tasks. I'm not quite sure how to label that properly so that it'll be used safely, which may be a little bit related to what you're talking about. It's definitely not good for everything if you've already scrubbed out the bias. Maybe I'm trying to study sexism in hiring, and you've made that impossible by doing some nonsense with the data. Right. That's an important issue, and communicating that properly with, you know, warning. We talk about nutritional labels sometimes. We're doing some work on how to slap nutritional labels on the data sets that we have. But that's a bit of an open question. My immediate concern, though, is that nobody's looking at any of these problems because it's too much of a pain in the ass to get the data. And it's a good problem to have if you have a lot of people that are scrubbing these things. But it's a great question. Sorry to miss it the first time.
A quick one?
Okay, just very quickly, a lot of companies in this software 2.0 trying to use data to build software and so on. Maybe we need a tool that can help them to find biases in the data or something like that.
And some of those tools exist.
They exist.
Yeah,
huh?
yeah. There's emerging. There's a thread of academic research, but then actually, as of the last 6 months, IBM's got a bias finding something or other that they released, and there's a couple other tools that have been released that are here. And then there's a NSF call backed by Amazon, which is a little bit, you know, big tobacco funding the cancer research kind of thing. But they're in a fairness in ML, and I'm sure some tools will come out of that as well. Yeah.
Great.
I'm more interested in the data side, the data management side, as opposed to the way downstream trying to correct the algorithms to be fair.
Sure.
Thank you very much, Bill. That ends the formal presentation portion of today. I'm going to hand it back to Jacek to have our closing conversation.
All right, great. Thanks, Todd. So we skipped the session, you probably remember, just after lunch. So let's talk about just a few minutes about the future of XLDB, next topics, locations, things like this. So I mean, as I said at the very beginning, we've been running this since 2007. We've been going from workshop to conference to multiple days to multiple locations, 3 days with tutorials. Like, you know, we tried many things. So the way I look at it is that every single year, the speakers, the quality of talks was superb. And I think this is true this year as well. I mean, I don't know what you think, but I loved every single talk. So from the perspective of attracting the speakers, it's a huge success. But it's not easy. I mean, it really takes an effort to find those speakers. It's maybe not so bad the first year, the second, but then you run out of your friends and families and, you know, colleagues, right? And you don't want to keep repeating. So that's one issue. So I think what I'm saying is that if you can help with finding those people, helping us reach out to new communities, help us come up with the ideas, what sort of topics, sessions we want to introduce, what sort of trends you see you would like to have us covered, then please participate, because there's a small group of us that's been around for 10, 12 years running the XLDB, but we need your help, we need your input. So that's the first message I have. And let's have a very quick kind of brainstorming what sort of topics we might want to see. The second is, how do we bring up the attendance? So at the peak, some of you may know, we had over 200 people coming to those conferences. That was a different time. Facebook didn't exist. Google was in a garage. We had a petabyte here at Slack. So very different times. We didn't have all those meetups about big data and stratas and things like this. So now there are just too many opportunities to discuss topics about the big data, and I understand it. So that's probably part of the reason. But in order to keep it successful, we need to have the right group of people, enough people to really discuss it, right? So, and then of course, like as I said, we are videotaping, and whoever agrees, the speakers, then we will put it on the YouTube. And I know that we are helping community, and there are thousands of views. So we are actually reaching out to a lot of people and helping out. But I keep thinking, what can we do to really build the right community so that we have enough people in the room to actually participate? Because what I'm feeling is that even though this room doesn't feel like it's empty, I think it's like, how the room is built. But if you would count, there's like, maybe 50 of us, right? So I think in order to have successful XLDB, we probably need a few more people, from different communities, right? So I'm just kind of bringing this up so that you can all think about it and like collectively, what can we do about it? How can we, do we want to continue, first of all, right? Because I mean, I will tell you frankly, I always have those dilemmas. Oh, it's so much work. This is like, an evening job in addition to the day job. And I think we are all feeling this. I mean, Katie, you will have LSST up in the sky running a couple of years from now. You are super busy as well, and others are as well. But at the same time, when I listen to those talks, it's like, oh, this was so worth it, right? So first of all, should we continue next year? Is it worthwhile? Would you come? Would you come back? That's the first question. So then the second question is, how do we bring others? Right, would you bring a friend? How many friends would you bring? And it's not about filling the room. No, it's not about the bodies sitting on the chairs. It's about like reaching out and helping other communities, reaching out to other groups that we didn't.
I actually see an opportunity here of collaboration through the year, not just on the conference.
Mm-hmm.
And I think forming, it might be just too idealistic, but forming groups of work around different topics through the year and getting those companies and academia involved on those things, I think that would bring up the audience and the people interested on this. For me, discovering this was searching Google without, like, it was really hard to discover, right? Whereas if there's products coming out of these or things that are, and I think the potential is here, right, to come up with new ideas or new things that are happening on cross collaboration, that will bring on the awareness of what is
right.
this, and then
and yes, and that I'm sure this would help. This would be great, but we would need people who can actually help us run those things, right? Because I can't be the only one, Katie can't be the only one. There's a couple of others people that are helping us, but we need more people who can take the lead. So, for example, if you would be willing to organize something, let's do it. We have mailing lists with thousands of people, like several thousands of people are watching. We have 600 plus or 700 that are on LinkedIn, but we are completely inactive, to be honest, right? I mean, if you look at the Twitter, there was, I think, one post on about XLDB on Twitter. I mean, look at other conferences, what they are doing. So I think that's part of the reason. If someone looks from outside, like even on our agenda, and I'm not blaming anyone here, it's probably me that's most to blame for it. Like, the agenda has title TBD, right, the day before the conference. So people who are looking from outside and don't know about XLDB, they will think, oh, this conference is not serious, right? So we have things like this, but again, it's about the little time to have this all kind of tighten up. You had a comment?
Yeah, I came here because I was at SysML, Systems for Machine Learning. That's why I came. But I just wonder, why don't you have it in conjunction with other relevant conference? For example, VLDB. Let's say I'm saying
right
because in VLDB a lot of good people will come anyway. So so then you can have very good speakers for your conference, something like that. This was just
right. Although I don't mean skew the dynamics. VLDB. This would skew the dynamics, right? Because VLDB is very much academic oriented, and we want to keep the balance.
Actually, it's getting more.
But
in some ways, they changed
No, but
Mike.
Yeah, they're changing also. They
They're-
haven't.
right.
I mean,
In some ways, they've
VLDB
changed
has
to kind
all
of
sessions
incorporate
about
the
industrial
space.
people.
Yeah.
So
Many of the people that
yeah.
gave talk here were in VLDB. I just want to tell you.
Right. So
Like, for
that's
example.
yeah. So yeah, I mean, we thought about it, but
this
maybe
is
we
just,
should.
I
We
mean,
should
I'm
really-
just brainstorming. I mean,
Right.
just
Yeah.
giving an
Exactly.
idea.
That's what we want. Yes.
exactly.
Perfect. Any other comments, suggestions about this topic?
Yeah, let me try just a few things. You know, I think about, I've been coming for a number of years. I sort of slipped away for a few. You know, the nature of what we talk about at this conference has changed so much, right? I mean, we talked about databases and query languages and data management, and now we've gotten away from that, probably appropriately so. I think what you were sort of saying was there's lots of places to talk about those things now, right? I mean, there's meetups and all kinds of things. I mean, the talks that interested me the most were the last two, to be honest, because they started getting into, well, especially the last one, you know, and KT and I were talking about this yesterday morning, sort of the ethics of machine learning and the ethics of the practice of it. You know, not saying it's good or bad, but, you know, should we try to pick topics that people can't hear about anywhere else, right? So that we're not lost in the noise of, you know, I can go to a data science meetup in San Francisco, you know, and probably get a lot of this material, right? You know, what can I only come here for? Right? Yeah, you know, what brings me back here is the quality of the speakers. I mean, I'm sort of convinced there are speakers I will hear here that I won't hear anywhere else just because it is small. But, you know, what about topics, right? I mean, I don't know how people feel about this. I'm just sort of throwing it out. Should we try to diversify a little bit and have a set of topics that are only, you know, talked about here?
And to some extent, we are doing this, right? I mean, we are picking the topics that are forward-looking, not just kind of common, something that's discussed elsewhere. So that always was the case. Something that's cross-disciplinary, that you know, the science and academia and enterprise.
It's true. It's just like, you know,
right.
the meetup ecosystem is now so vibrant in all of these areas, right? I mean, maybe we need to like take a 30,000-foot view and
right.
and see if there's a better niche.
Right. The uniqueness that we have is the mix of the communities. Because, I mean, we have one person from Geneva, but we don't have many people from like CERN type places. But we can bring them, right? I mean, if we make a little bit more effort, then we can bring people from NASA, from DOE labs, from CERN, and mix them together with you know, with MIT, with enterprises. So that's the very unique, I think, aspect that very other venues, conferences, meetups have. So in terms of topics, what any thoughts? And we will send a survey, by the way. And feel free to send email anytime to me or KT, and we will listen. But any topics that come to mind that you would like to hear about? Any themes? Anything like, you know, new trends that keep, like, you know, you keep thinking about that we should?
I think a couple things came up during the conversations today around anonymizing data and privacy and big data, and relates to the ethics topic that you talked about. That's
right.
certainly one that I think has interest within the community.
Right.
You know, Jacek, it's kind of a meta topic as opposed to a specific one, but I really liked Chris's comment earlier today. He said the feedback that he wanted most was, here's the problems that I think your stuff can't solve.
Right.
And I think that is what was great about the early XLDB conferences, because we were talking about the data problems that none of the existing technologies could solve,
Sure.
right? And I that's where I really got my value from the conference over the many years, was hearing problems that, you know, might be problems in the medical arena, might be problems in high energy physics, it might be problems in oil and gas exploration, wherever they may be. Bring us the problems that aren't solved by, you know, off-the-shelf
And the
technology. I don't want
constraints
to
and
hear another
why.
Hadoop conversation. I got plenty of those, right?
Yeah, good point. Any Any other suggestions? You are shaping the next, next XLDB in big ways. So, all right. So think about it more. Ask your friends. See, and we will be collecting this right after the conference and anytime. We will put you on the XLDB mailing list unless you want to opt out. It's easy to opt out, but hopefully you will want to kind of stay connected. It's very low traffic list. So we will send a survey. We also part of the survey will be asking for the votes for the lightning talks. So if you like anyone particularly, then let us know, and then we will give the speaker half an hour or so. So pretty much the full slot at the next event. We've been also discussing briefly the possibility of maybe doing one somewhere else, like Asia, for example, in China. So that's another option that we could do. We've done it in the past. We had one conference in China. So there's interest in organizing it again. So we will think about it. Instead of one here or in addition to one here. So again, we will kind of explore it, but I'm giving you the preview where what's kind of brewing. What else? So Katie, any other thoughts? I wanted to thank all the sponsors, the organizing committee. I mean, honestly, without them, we wouldn't have the conference, and I wanted to thank you all for coming and staying until the end, because again, we wouldn't have the conference without you. So thank you very much, and hopefully I will see you through the year and at the next XLDB. So thank you.